Hello everyone, I am Muhammed Selahattin Koyuncu. I want to talk about our project. To begin with, we decided to use rainfall water that is fall roof of the civil engineering faculty to generate energy. However, after simple calculations, it seems that income of the project is not satisfying. After small searching, electrolysis article faced with us. By using the information and techniques that is available in the article, gives us an idea. We decide to set a small electrolysis plant which is sourced by rainfall. Without any extra energy or any extra sources, generated energy become bigger. Here's our project. Determination of area prepared by Mert Demirkol and precipitation which is prepared by Utku. Turbines prepared by Batuhan Mirza Kıvancı. And here, prepared by me, I will explain here. And the electrolysis part prepared by Mert Demirbüken. Let's talk about how do we do power and energy calculations. Here, there is an Excel table which is prepared by me. By using the weather condition data, we found the Q, mean flow value, and because of we can determine what is the suitable diameter for us, we calculate for different diameters. V for mean Q is founded by Q over area of different diameters pipe. And then H loss is calculated by the formula that is we are familiar from the hydraulic and this kind of classes here. And then we found the HN. Actually, our building height is 70.4, but kind of H losses, we need to calculate the net height of our building. And then gamma watt is founded by as a kilonewton over meter square. End of this kind of information, we finally find the power of turbines by using Q, gamma water, Hn, and efficiency. Efficiency is founded by Batuhan Mirza Kıvancı as a 0.74. We found the power of the turbines produced by turbines. After that, calculated rainfall duration, which is 818 hours, is used in the energy calculation. Energy is equal to power multiplied by hour. We found the turbine energy as a 498.6 kilowatt hour. After that, we use it here in the Mert Demirbüken's part to calculate the generated energy from electrolysis. That is here.
Hello everyone, my name is Mert Dinçko. I will tell you about determination of the roof area. The roof area required for the calculation of the renewable energy system we plan to install on the roof of the Faculty of Civil Engineering at the Istanbul Technical University Ayazar campus. Using the Google Earth Pro application was calculated to find the total amount of precipitation. After calculating the entire area, the area of the gardens was subtracted. The area is 10,734 square meters. While finding the total precipitation amount, we get the amount of water from the total precipitation by multiplying the precipitation data from the General Directorate of Meteorology with the roof area. It is assumed that the amount of water that will come from the roof area will go to renewable energy plant throughout a single pipe. So it is thought that one-way slope will be provided to the roof. Guys, as you see, it is our faculty, Istanbul Technical University. The area of guidance was subtracted.
Hi everyone, I am Utku. I am going to talk about the precipitation side of the project. The greatest quantity of precipitation each day is 112.5 millimeters. According to the information we obtained from the Turkish State Meteorological Service official website. For a day, when the amount of precipitation was so great, we also factored in the water velocity in the pipe. Accepting that the rain will fall in January will progressively flow until June in order to design this project for average precipitation. The quantity of wet days was therefore calculated, and it was hypothesized that the turbines rotated exclusively on rainy days. The information we were given indicates that Istanbul experienced rain on 103 days per year. During the other sides, on the wet days, it will typically rain for 8 out of every 24 hours. This number was produced using a straightforward Excel table. Rainy days add up to 8 hours when they are combined together and divided by the total number of rainy days. So it may be argued that the day is rainy for one-third of time. When taking into account times, we calculate that it will rain non-stop for 36.68 days by dividing the 110 days by 3. In other words, the system and the turbine will each function for a total of 36.67 days. Because we measured our energy usage in hours, we dedicated that the system operated for 880 hours by multiplying by 36.67 by 24.
Hello, today I will talk about the hydrokinetic turbines. These are a type of turbines placed underwater as a fixed, floating, anchored, or towed in order to generate energy. The location of turbines must be where in the effective water current flows with a minimum speed about 0.25 meter per second. Hydrokinetic turbines will be used a lot in the future thanks to their potential to be used wherever there is a water flow and the production of clean and renewable energy. To talk about classifications briefly, cross flow with perpendicular axis, horizontal or vertical to the free surface, and flow, and axial turbines with parallel axis and flow are the main topics of the hydrokinetic classifications. The first type, cross-flow hydrokinetic turbines, also known as vertical axis turbines, capture kinetic energy of moving water with spinning plates oriented perpendicular to the direction of flow. And the second type is the axial flow hydrokinetic turbines, having a horizontal axis parallel to the water flow. And talk about selected and optimizations. The dimensions required for the project are not available in the literature. For this reason, optimization studies were carried out based on a study from the Journal Energy for Sustainable Development within Science Direct. The hydrokinetic turbine type chosen for the project is axial flow hydrokinetic turbines. The diameter value used in the project based on is 1 meter, but in our case, it is 10 centimeters was used. For this reason, the values here were divided by 10 and used for calculations. And the last thing, conventional hydrokinetics turbines have a rate of 20-25%. This rate reaches up to 86.5% in turbines inside the channel, according to the journal Renewable. In this project, this rate will be used as efficiency, and it has been determined as 0.74. 85% of this value was taken by using a 15% margin of error. So that's all I have to talk about. Thanks for your listening.
Hello everyone, I am Mert Demirbüken and I'm going to talk about the working details of the energy production from hydrogen system. In the system, we put the water into electrolysis machine. The reason of we used electrolysis system that we need to obtain only hydrogen molecules. Electrolysis machine help to divide water molecule to hydrogen and oxygen molecules. Extremely little energy is required for the electrolysis machine to operate. In the system, this amount of energy can be provided by solar farms, wind farms, and water turbines. After providing the energy needed to operate electrolysis machine, the water inside the machine breaks down into hydrogen and oxygen molecules by using the energy from renewable energy systems. Oxygen produced by electrolysis is not needed, so it released to air in gas form. In line with our main aim, hydrogen gas transported into hydrogen storage. Stored hydrogen can be used when needed by moving to fuel cell. Fuel cell provides favorable conditions to connect oxygen and hydrogens. Oxygen is taken from air. In the exothermic chemical reaction of combining hydrogens and oxygens, it produced water vapor and energy. Produced vapor released to air. The produced energy transferred to power station from fuel cell. The electrical energy can be used from power stations. To talk about our project, the main aim of our project is reducing the cost of electricity demand of our civil engineering faculty building. In our project, it planned to use rainfall water as resource of the system. The necessary energy to operate electrolysis machine, we placed water turbines into water pipes. The electrolysis machine we planning to use can produce 1 kilogram of hydrogen by using 1.55 kilowatt-hour energy. To produce 1 kilogram of hydrogen, we need to use 10 liters of water. It means 9% of hydrogen cannot use during the electrolysis. So the efficiency of electrolysis is 91%. 10 liters of water and 1.55 kilowatt-hour energy used to produce 1 kilogram of hydrogen, and after we produced 33 kilowatt-hour energy by using 1 kilogram of hydrogen. In our project, the limiting factor is the energy coming from water turbine. As a result of the calculation, we can use only 498 kilowatt-hour energy to operate electrolysis machine. When we corrected the ratios, 3.22 meter cube water using to produce 321 kilogram of hydrogen. In the end, 114 kilowatt-hour energy produced by this method. To sum up, by storing the hydrogen using hybrid system, we can produce 21 times more electric energy than the energy that can be produced with turbine. The reason of that difference between the two energy producing systems, hydrogen has extremely low density, so it can be stored highly efficiently and easy. When it compared with the other systems as solar, wind energy systems, those cannot store that easy. Thank you for listening.